a vertex of 0, 0, 0, yeah. What did we change when we did the lesson on Friday? So what was changing?
The shape, the parabola.
Yeah. So the shape. What's my original parabola?
One x.
Okay. So the original parabola is y equals x squared. And what did we add to that y equals x squared on Friday? So what was the equation of the 2x squared, half x squared,
Yeah.
right? Negative 2x squared. So what letter did I use for that?
A.
Okay. And we said that if a is greater than 1, we said that if a is greater than 1, then I have a vertical stretch. And we said that if a is between 0 and 1, then we have a vertical compression. And if a is negative, what is it called? That reflection. If a is negative, then we have a reflection. So the reflection happened with one of these two. Okay? So we'll have a reflection with a vertical stretch, or we have a reflection with a vertical compression. But sometimes we also have just a reflection, right? So if I have y equals negative x squared, right? That's only a reflection. There's nothing else. It's a reflection in the x-axis. Period. Done. Let's move on. Okay? So if a is negative, then we have a reflection in the x-axis, right? And we said that this a, does it affect the vertex? Does the a affect the vertex? No. Okay? It does not affect the vertex. So the vertex stays as what was the vertex for all of them? 0, 0. Right? And it does not affect the axis of symmetry. It does not affect the optimal value. Right? It just stays the same. We said that it only affects the step pattern. Yeah? Do you remember what the step pattern is?
1, 3, 5.
Okay, so the step pattern is 1, 3, 5.
Yeah.
Then remember that the step pattern is multiplied by a. So it's a times 1, 3, 5. Okay? So that's something that by that. Okay? So if a is 2, what would your step pattern be? 2, 6, 10. If a is a half, 0.5.
1.5.
Yeah.
2.5.
And 2.5. Yeah, so your step pattern becomes 1.5, 1.5, and so it will be 0.5, 1.5, and 2. And we said that we always start at the vertex, and then we go up by how many units it tells us to go up, right? Or go down. So if it tells us to go up by 0.5, you go up 0.5, right? If it tells us to go up 1.5, you're going to have to count 1.5. So this is the deal with a, okay? So when I have something multiplied by the x squared. Now the question is, what if I have some other kind of transformation? So what if I have something added to the x squared? So y equals x squared plus something, or minus something, okay? So I need you guys to go to this lesson right here. So you see this page? Just skip this page for now. I don't want you to look at this page for now. Just go to the next page, please. by itself, you have nothing added to it, correct?
Yeah.
So that's going to be plus 0, right? So your k value is 0, and there's nothing. That's why we don't write it, right? Your k value is 0 in this case. And then we said that when I have this, the direction of opening is up, the vertex is 0, 0, the axis of symmetry is x equals 0. This is my parent function. Now, what if I have x squared plus 2? What do you think is going to happen?
Minimum part goes to downwards.
Why downwards?
Not sure why it works.
Okay. You think it's going to be downwards?
Actually, no, I'm thinking in my mind. I think it's gonna be upwards.
So what's going to happen to you, do you think, to the graph?
But the minimum value will be at 2.
Okay, so you think that the minimum value is going to be at 2. So in my original function, right, I had the minimum at 0, right? That's my original function. So you think now that the whole graph,
It's gonna go 2 spaces
so it's going to move 2 spaces up.
up.
So you see that, you think that it's going to go up to 2. Is that what you think? Okay, and why is that? Why do we think that? Do you guys agree with this? Yes, no, maybe? Yes, Ahmed, why do you think that is?
Because you're adding 2 to it, so it's going up positive 2. Graph's going up by positive 2.
And what's going up by positive 2? What value is going up by 2?
The y1.
The y value, right? So the x is not changing, right? The x, I'm still plugging in the same number, but what's happening, whatever my x is, right? So let's say x is 2, right? You have 2 squared, right? And then plus whatever the value is. So 2 squared is 4, plus whatever that value is, which is going to bring the y up by that value, okay? So let's see at, let's use Desmos. So I want you to use Desmos to graph y equals x squared first, and then we're gonna graph y equals x squared plus 2 on that, okay? So make sure that you always graph the y equals x squared, which is your parent function.
Okay.
Okay, so that's my original function. Now I'm gonna add to it y equals x squared plus 2. Ahmed, you were right. So you see that my whole graph has shifted up 2. Okay? It shifted up 2, that means that's a vertical shift. Okay? Anything that's up and down, that's vertical. Okay? So we have a vertical translation. It translated 2 units up. So in this case, what's changing? What is my vertex now? What's that vertex right here? Vertex is a point, so it should have x and y values. 0, 2. So my vertex here is 0, 2. What part of the vertex has changed? The x part or the y part? The y part of the vertex has changed. So it's affecting the y values. Okay? Now what would be your second graph? What's the second equation that you have? Y equals?
X squared plus 4.
Okay? You see, now, remember, we always compare to the original, so we always compare to the red one in this case, right? So we see that now my graph has shifted 4 units up. So we call that a vertical translation, 4 units up. What's my vertex for this one? 0, 4. Okay? If I'm going to graph an axis of symmetry, where's my axis of symmetry? At x equals 0, right? Is the axis of symmetry changing? No. Right? Because remember, guys, if you go back here, if I look at all my vertices, right? If I look at all of these, they all have the same x value, right, which is 0. And remember that the x value of the vertex is the axis of symmetry. Okay? Now, are they all opening up?
Yes.
Still? Okay? They're all opening up. Perfect. Now, what would be my next one? Y equals what? X squared minus 1? So what do you think is going to happen?
It's just gonna move down.
It's going to move down. So my original graph is going to move down. Is it going to flip?
No.
No, it will not flip. What causes a flip? What causes a flip? What causes a reflection? The A value. If the A is negative, that's the only thing that causes a reflection. Okay? So let's do this. Minus 1. Okay? You see the purple? Right? The graph's still opening up. It's just what happened is I actually shifted it down. Okay? So it's like I have this table and I shift it right or left. Right? Or in this case, up or down. Okay? So I take it and I shift it up. I don't change the shape of it. Nothing. I'm lifting it. Okay? So in this case, the vertex is 0 and negative 1. Okay. So let's go to this. And then what do you expect for x squared minus 3? So vertical translation, we're going to have to use these words. Vertical translation, 3 units down. What would be the vertex? 0, negative 3. Okay, so let's write these down. So the value of k is 2. Direction of opening up. Vertex 0, 2. Axis of symmetry, x equals 0. And then with respect to y equals x squared, we had a vertical translation. So we use VT for that. So we had a vertical translation, 2 units up. What's the k value for y equals x squared plus 4? What's the k value? Direction of opening? Vertex? Axis of symmetry. And a vertical translation, 4 units per. For y equals x squared minus 1, the k value is minus 1. Direction of opening, up, vertex, axis of symmetry, and vertical translation, 1 unit down. Next. And then the last one is the k value is negative 3. Direction of opening is up. The vertex is 0, negative 3. Axis of symmetry is x equals 0. And I have a vertical translation, 3 units down. Any questions about this? So, when k is greater than 0, then the parabola shifts. When k is greater than 0,
Up.
the parabola shifts up. When k is less than 0, the parabola shifts
Down.
down. The k value describes the vertical translation of the parabola. It is known as the y value of the vertex. I'm just going to write this here because I have more room. Now, if I look at the y value of the vertex, what else do we call that? The optimal value. Okay? So remember that if I have my vertex here, right? This here is my optimal value, right? So whatever the y value here, that's my optimal value. Okay? So that's when I have something added to the x squared. So when I have y equals x squared plus or minus something, okay? We call that something k value in this case. We call it the letter k, right? Some textbooks, some other textbook might call it d. Some other textbook might call it whatever, right? But it's the same idea. You have your function, which is x squared, and then you're adding or subtracting something to it. Now, let's look at how can we graph this. Okay, right, to figure it out. But let's see how can we graph it as if we're going to sketch it ourselves. So what kind of transformation do I have here? So y equals x squared plus 3. What kind of transformation, if you're going to state the transformation part? What are you going to say? Vertical translation, 3 units up. I'm looking for the whole sentence, guys. I'm not looking for 3. I'm not looking for 3 units. I'm not looking for just moving up. I'm looking for the whole sentence. Okay? That's why I take the time to write it for you. You have to take the time to write it for me. Okay? So, you're going to say it's a vertical translation, 3 units up. Practice your sentence. Now, that's it. That's all the transformations I have, right? Nothing else. Now, in order for you to graph, what do you need? What do you need in order for you to graph?
First, the parent function.
So we can graph the parent function if we want. We don't need it here. It's not asking us for it. But what do you need when you're graphing any quadratic? What do you need first?
The value of A. The value of A.
One at a time, please.
The value of A.
No?
The y-axis and the x-axis.
Okay, we can put the y and x-axis. I'm looking for a certain point. What point do we need to start with? The vertex. Okay, so I need the vertex. Okay, what's the vertex here? 0, no, 0, 3. Okay, so the vertex is 0, 3. Because remember, the k affects the y value of the vertex. Now I also need something else. So I have the vertex. What else do I need to graph? Go ahead, Matthias. Carlos. Sorry? Okay. Go ahead, Carlos. Step pattern. What's the step pattern? So first I have to locate the vertex. Second, I have to use my step pattern to graph the next points. Okay? So So I'm gonna start at the vertex, which is 0, 3. So I'm gonna start at the vertex, 0, 3. And then my step pattern says what? Where do you see 3 units up?
1, 3, 5.
Okay, I located my vertex, then what do I have to do after that? Okay, so from here, where do I go?
1, 1,
Up 1,
yeah.
then,
1 up over 3.
nope.
No. 1. No, 3 up.
So go up 3, 1, 2, 3,
1
over 1.
1.
Okay. Now, if you look at the next one, I can't go up 5, so I don't have room on my graph. I can stop. As long as you can fit 5 points on your graph, that's good. Okay. So, eyes on me for a second. From the vertex, I go up 1 over 1. Then up 1, 2, 3 over 1, because my step pattern says 1, 3, 5. If I had room, I will go from this new point 5 up. But I don't have that, so I don't have to graph it. Now, to graph the other points on the other side, you do the same thing, but to the left. So up 1 to the left 1. Up 3 to the left 1. Okay? Now you see that you have your parabola shape, and then you can sketch it. So you start at your vertex, and then you follow your step pattern. Okay? Now, I want you to take the time to do the second question, please.